In 2025, Manaus remains one of the most isolated major cities on Earth, now home to over 2.4 million people, sitting in the heart of the Amazon, with no bridges crossing the mighty river and no continuous land route connecting it to Brazil's coast thousands of kilometers away. Yet from this unique urban outpost, researchers using LIDAR technology have discovered massive ancient cities hidden beneath the rainforest canopy, including the groundbreaking 2024 mapping of the Upano Valley that revealed settlements supporting tens of thousands of people over 2,500 years ago. These discoveries from Manaus are rewriting our understanding of what lies beneath the Amazon's green ceiling. But to grasp the true scale of what remains hidden, you first need to understand just how vast this rainforest really is. The Amazon's staggering 2025 scale. The Amazon rainforest stretches across 6 million square kilometers of South America in 2025, covering territory equivalent to roughly 3/4 the size of the contiguous United States. This massive green expanse dominates the northern half of South America, with Brazil containing approximately 60% of it within its borders, while Peru holds about 13%, Colombia 10%, and the remaining portions spread across Bolivia, Venezuela, Guyana, Suriname, French Guiana, and Ecuador. Despite occupying this enormous landmass, the entire Amazon region supports only about 30 million people as of 2025, creating one of the lowest population densities on Earth at roughly 5 people per square kilometer. This sparse population means the Amazon could theoretically fit the entire population of South Korea and still maintain lower density than most European countries. The population distribution reveals something remarkable about where people actually choose to live within this vast wilderness. Current satellite data shows that 78% of Amazon residents cluster within 50 kilometers of major rivers, leaving massive inland territories with population densities below 1 person per square kilometer. Some areas in the Brazilian states of Amazonas and Pará record densities as low as 0.3 people per square kilometer, making them less populated than the Sahara Desert. This clustering effect means that roughly 4.2 million square kilometers of Amazon territory remain essentially uninhabited by permanent settlements. Modern satellite imagery from 2024 and early 2025 reveals the staggering scope of unexplored terrain that persists despite decades of technological advancement. The forest canopy creates an impenetrable barrier that conceals whatever lies beneath, and until the advent of LIDAR technology, most ground details remained completely hidden from view. Even with advanced imaging capabilities, researchers estimate that vast sections of the Amazon have never been systematically surveyed on the ground. The paradox becomes even more striking when considering the technological capabilities available in 2025. Satellites can now detect objects as small as 30 centimeters from space. Drones can penetrate forest canopies with specialized sensors, and GPS tracking allows precise navigation anywhere on Earth. Yet massive sections of the Amazon remain as mysterious and inaccessible as they were centuries ago. The forest itself acts as a natural shield, with triple-layer canopies blocking visibility, dense undergrowth preventing easy movement, and complex river systems creating natural barriers that modern technology struggles to overcome efficiently. This technological limitation has profound implications for understanding what the Amazon conceals. Ground-penetrating radar can only operate effectively when researchers can physically transport equipment to survey sites, but reaching many locations requires weeks of river travel, followed by days of hiking through unmarked terrain. Helicopter access remains limited by fuel capacity and landing zone availability, while fixed-wing aircraft cannot penetrate the canopy to deliver detailed surface information. The result is a situation where humanity possesses the technical ability to map distant planets more thoroughly than significant portions of our own rainforest. Recent data compilation projects have quantified exactly how much Amazon territory remains unmapped. The Brazilian National Institute for Space Research reported in late 2024 that approximately 2.1 million square kilometers of Amazon rainforest had never been surveyed by ground teams, while an additional 900,000 square kilometers had only been visited once or twice by researchers. These figures exclude areas that have been photographed from aircraft but never accessed on foot, which would push the unmapped total even higher. The transportation infrastructure that might enable deeper exploration remains virtually non-existent across vast Amazon regions. Only 12% of the Amazon basin currently has road access within 10 kilometers, and many of these roads become impassable during rainy seasons that can last up to 7 months annually. River transportation provides the primary access method for most areas, but the Amazon River system includes over 15,000 tributaries, many of which have never been fully navigated or mapped. This creates a situation where reaching unexplored areas often requires custom expedition planning that can take months to organize and execute. The challenging access conditions have inadvertently preserved whatever secrets lie hidden beneath the forest canopy. Archaeological sites that might have been discovered and potentially disturbed decades ago in more accessible regions remain untouched simply because no one can reach them easily. The same transportation barriers that frustrate modern researchers also protected ancient settlements, indigenous territories, and natural ecosystems from outside interference for centuries. What makes this situation particularly intriguing is that recent discoveries have emerged from areas that seemed completely inaccessible until new technologies made limited exploration possible. The most significant archaeological finds of 2024 occurred in regions that required helicopter access combined with specialized ground equipment, suggesting that the most important secrets may be concentrated in the most difficult places to reach. The clustering effect of major discoveries around specific access points creates an interesting geographic pattern. Most significant archaeological sites identified in recent years lie within 200 kilometers of either major urban centers or river confluences that allow boat access. This distribution suggests that vast interior regions, particularly those more than 300 kilometers from navigable waterways, remain almost completely unknown. These remote zones represent roughly 40% of the total Amazon area and could contain the largest concentrations of undiscovered sites. Current exploration efforts focus on establishing strategic base camps that can serve as launching points for deeper penetration into unmapped territories. The most ambitious projects planned for 2025 target areas that have never been visited by researchers, and they all depend on one crucial urban outpost that serves as the gateway to the Amazon's deepest mysteries, Manaus, the isolated metropolis in 2025. That outpost is Manaus, standing at the confluence of the Rio Negro and Solimões rivers as a sprawling urban island of concrete and steel completely surrounded by an unbroken sea of green rainforest canopy that extends to the horizon in every direction. This Brazilian metropolis now houses 2,434,640 residents as of 2025, making it the 7th largest city in Brazil despite sitting in one of the most remote locations imaginable for a major urban center. The city has grown by roughly 1.15% to 2.43 million people, adding thousands of new residents to an already crowded metropolitan area that exists hundreds of kilometers from the nearest comparable population center. The growth statistics become even more remarkable when you consider that Manaus sits roughly 1,500 kilometers from Sao Paulo and 1,700 kilometers from Rio de Janeiro with no direct road connections to either city. The nearest major urban area is Bogotá, Colombia, which lies about 1,100 kilometers to the northwest, while Lima, Peru sits approximately 1,400 kilometers to the southwest. This geographic isolation makes Manaus the most isolated major city in the Western Hemisphere, yet its population continues expanding at rates that exceed many coastal Brazilian cities with direct highway access to the rest of the country. The economic magnetism that draws people to this remote location stems largely from the Manaus Free Trade Zone, established in 1957 to encourage industrial development in the Amazon region. This special economic zone offers significant tax incentives that have attracted 600 companies to establish manufacturing operations in the city, creating 108,373 direct jobs, according to recent industrial statistics. Major global corporations operate large-scale production facilities in Manaus, manufacturing electronics, appliances, and consumer goods that serve both Brazilian and international markets. The city's industrial success creates a unique economic paradox, where multinational corporations transport raw materials thousands of kilometers into the Amazon, process them in modern factories, then ship finished products back out through the same complex logistics networks. This arrangement works because the tax advantages offset the substantial transportation costs. But it also means that Manaus depends entirely on maintaining reliable supply chains that stretch across vast distances. Components for electronics manufacturing arrive by cargo ship up the Amazon River from the Atlantic Ocean, while finished products often travel the same route in reverse, creating a constant flow of commercial traffic along the waterway. Daily life in Manaus operates under constraints that residents of most major cities never experience. Power generation depends on a combination of hydroelectric facilities along Amazon tributaries and thermal plants that burn fuel transported upriver, while water treatment systems process river water that flows from across the entire Amazon basin. The city's infrastructure must account for seasonal variations in river levels that affect everything from port operations to waste management systems. The city serves as the primary staging ground for virtually all serious Amazon research and exploration activities. Scientific expeditions planning to penetrate deep into the rainforest typically spend weeks in Manaus organizing equipment, hiring local guides, and coordinating with research institutions based in the city. The Brazilian National Institute for Space Research operates a major facility here that processes satellite data covering the entire Amazon region, while international organizations maintain permanent offices to support ongoing conservation and archaeological projects. This concentration of expertise and infrastructure makes Manaus indispensable for researchers attempting to access remote areas of the rainforest. Recent archaeological discoveries that have captured international attention originated from expeditions launched from Manaus. The city's port facilities allow researchers to load specialized equipment onto boats that can navigate smaller tributaries, while the local airport handles helicopter transport to sites that boats cannot reach. Storage facilities in Manaus house artifacts and specimens collected from across the Amazon, and laboratories here process initial analyses before shipping samples to universities worldwide. Without this urban infrastructure, most significant Amazon discoveries of the past decade would have been impossible to achieve. The transportation networks that connect Manaus to the outside world reveal both the city's importance and its vulnerability. Commercial flights link Manaus to major Brazilian cities multiple times daily, but weather disruptions can easily ground air traffic for days at a time. River transport remains the primary method for moving heavy cargo, but seasonal water level changes affect navigation schedules throughout the year. During dry seasons, larger vessels cannot reach the city's main port facilities, while flood seasons can make river navigation dangerous due to increased current speeds and floating debris. Supply chain disruptions that would merely inconvenience other cities can create serious shortages in Manaus. When river levels drop below critical thresholds, fuel shipments may be delayed for weeks, affecting everything from power generation to transportation within the city. Food distribution networks that depend on refrigerated transport face particular challenges during the rainy season when connections to agricultural areas become unreliable. The city's role as a gateway to Amazon secrets extends beyond scientific research to include ecotourism, indigenous community liaison work, and environmental monitoring programs. Tour operators based in Manaus organize expeditions to remote areas where visitors can observe wildlife and traditional communities, while environmental agencies coordinate forest protection efforts across multiple countries from offices here. Government agencies responsible for indigenous affairs maintain regional headquarters in Manaus, facilitating communication with communities scattered across territories larger than many European countries. Manaus represents humanity's most ambitious attempt to establish a major urban center in the heart of Earth's largest rainforest, demonstrating that modern technology and economic incentives can support millions of people in locations that seemed impossible for large-scale settlement just decades ago. Yet maintaining this urban success requires overcoming transportation challenges that would test even the most advanced logistics systems. And these same barriers that make daily life complicated also determine which Amazon secrets remain accessible to discovery. The transportation maze of 2025. Getting to Manaus in 2025 still means navigating one of the most complex and unreliable transportation networks on Earth, where a journey that should take hours can stretch into days or weeks, depending on weather conditions, river levels, and the seasonal whims of an untamed wilderness. Despite decades of promises and billions of reais in proposed infrastructure spending, the fundamental challenges of moving people and cargo through the Amazon remain largely unchanged from previous decades. Brazilian Highway 319 continues to serve as a major overland route connecting Manaus to the rest of Brazil, but significant portions of this 900-kilometer road remain unpaved as of early 2025. The Brazilian Senate approved legislation in late 2024 that weakens federal environmental licensing powers, potentially clearing the way for complete paving of BR 319 by streamlining the approval process from 3 bureaucratic steps to 1. However, environmental groups have mounted fierce opposition to this project, arguing that full paving will trigger massive deforestation in pristine rainforest areas that currently remain untouched precisely because the road access is so difficult. The political battle over BR 319 has delayed construction work that was originally scheduled to begin in 2024, leaving hundreds of kilometers of the route in the same muddy, seasonal condition that has frustrated travelers for decades. During the dry season from June through November, the unpaved sections become dusty obstacle courses lined with deep ruts and washboard surfaces that can destroy vehicle suspensions. When the rains arrive, these same stretches transform into impassable mud bogs where vehicles regularly become stuck for days while waiting for conditions to improve or help to arrive. Even when travelers successfully navigate the highway system, they still face the reality that the Amazon River system lacks a single bridge crossing along its entire 6,400-kilometer length, forcing all ground transportation to rely on ferry services that operate on schedules dictated by river conditions rather than passenger convenience. Ferry crossings at key points along the transportation network can involve waits of several hours during peak travel periods, while mechanical breakdowns or severe weather can shut down ferry operations entirely for days at a time. The ferries themselves range from modern car-carrying vessels to small motorboat operations that can handle only a few vehicles per crossing, creating bottlenecks that ripple throughout the entire regional transportation system. River transportation remains the backbone of Amazon logistics, with the Amazon River navigable by ocean-going vessels for roughly 2/3 of its length from the Atlantic Ocean to Manaus. This waterway supports everything from massive cargo ships delivering manufactured goods to floating gas stations and convenience stores that cater to the constant boat traffic. However, seasonal water level variations create their own set of challenges that affect everything from cargo delivery to scientific expeditions. During peak flood season from December through April, many tributaries become too dangerous to navigate safely due to increased current speeds and floating debris, while the dry season from August through October can lower water levels enough to ground larger vessels entirely. Research expeditions attempting to reach remote archaeological sites face logistical nightmares that can consume months of planning and tens of thousands of dollars in transportation costs alone. A typical expedition to an unexplored area might require chartering a cargo plane to fly equipment to a remote airstrip, then transferring gear to helicopters for transport to a river access point, followed by days of boat travel upstream to reach base camp locations. Weather delays can strand research teams for weeks at remote sites when scheduled pickup flights cannot operate, while equipment failures in the field often mean abandoning expensive scientific instruments because retrieval costs exceed replacement costs. Small aircraft and helicopter access has enabled virtually every major Amazon discovery of the past 5 years. But this transportation method brings its own constraints that shape what can be found and studied. Helicopter fuel capacity limits operating ranges to roughly 300 kilometers from established fuel depots, while landing zone requirements restrict access to areas with suitable clearings or riverbank access points. Fixed-wing aircraft require prepared airstrips that exist in only a handful of locations throughout the vast Amazon region, concentrating exploration activities around these limited access points. The economics of helicopter transportation create a situation where research expeditions must achieve significant results quickly to justify operational costs that can exceed $15,000 per day. This time pressure often forces researchers to focus on sites that show immediate promise, rather than conducting the systematic surveys that might reveal less obvious archaeological features. These transportation limitations have inadvertently created some of the best protection for undiscovered archaeological sites throughout the Amazon region. Areas that would have been thoroughly explored and potentially disturbed decades ago in more accessible regions remain completely untouched, simply because the cost and complexity of reaching them exceeds the resources available to most research projects. The same geographic barriers that frustrate modern transportation also prevented historical looting or development that destroyed archaeological sites in other parts of South America, preserving ancient mysteries in locations where conventional access remains nearly impossible to establish. Yet recent technological advances have begun to overcome these transportation barriers in ways that seemed impossible just a few years ago, revealing secrets that had remained hidden beneath the forest canopy for centuries. LIDAR revolution, seeing through the canopy. The breakthrough came when recent advances in the 2020s revolutionized archaeological mapping through aircraft-mounted laser scanners that could penetrate the Amazon's triple-layer forest canopy and map the ground surface beneath with unprecedented precision. LIDAR technology fires millions of laser pulses per second downward from aircraft flying at altitudes between 500 and 2,000 meters above the forest. These laser beams slice through gaps in the vegetation and bounce back to sensors that measure the exact time it takes for each pulse to return, creating detailed three-dimensional maps of terrain features that remain completely invisible from above. The technology can distinguish between laser reflections from treetops, middle canopy layers, and the actual ground surface, effectively removing the forest digitally to reveal whatever lies beneath. The laser scanning process generates detailed topographical maps showing elevation changes as small as 10 centimeters. This level of precision allows researchers to identify artificial structures like ancient roads, building foundations, agricultural terraces, and ceremonial platforms that appear as subtle variations in ground elevation. Features that would be completely invisible to researchers walking through dense forest become clearly visible in LIDAR data as geometric patterns that stand out against the natural randomness of forest floor topography. Major LIDAR mapping projects completed in 2024 covered approximately 45,000 square kilometers of previously unmapped Amazon territory across Brazil, Peru, Ecuador, and Bolivia. The Brazilian Amazon LIDAR Initiative, funded jointly by the Brazilian government and international research institutions, completed high-resolution surveys of 23,000 square kilometers in Para and Amazonas states during the 2024 dry season. These surveys targeted areas identified through satellite imagery analysis as having potential archaeological significance based on subtle vegetation patterns and geometric clearings visible from space. The Ecuador Amazon Archaeological Project completed LIDAR mapping of 12,000 square kilometers in the Upano Valley region during late 2024, revealing what researchers describe as the most extensive pre-Columbian settlement network ever discovered in the Amazon basin. The survey identified more than 6,000 individual structures organized into at least 15 major urban centers, connected by a road network spanning over 300 kilometers. Initial ground truthing expeditions confirmed that many of these structures represent sophisticated architectural achievements, including residential complexes, ceremonial platforms, and agricultural infrastructure that supported populations far larger than previously thought possible in rainforest environments. The Peru Amazon Heritage Survey mapped 8,000 square kilometers along the Ucayali River watershed in early 2025, uncovering evidence of at least 2,400 previously unknown earthwork constructions. These include geometric earthworks, similar to those found in Bolivia's Llanos de Mojos region, suggesting that complex societies develop sophisticated landscape modification techniques across vast areas of the Amazon basin. The survey data indicates that many of these earthworks were connected by elevated roadways that remained functional during seasonal flooding, demonstrating advanced engineering capabilities that allowed year-round transportation across challenging terrain. LIDAR surveys revealed thousands of hidden sites across multiple countries, fundamentally changing our understanding of Amazon archaeology. The Upano Valley discoveries alone revealed urban planning on a scale that rivals Maya cities in Mexico and Guatemala, with residential areas, public plazas, and monumental architecture organized according to sophisticated design principles that maximized both defensive capabilities and agricultural productivity.